And welcome back. It is the night before Christmas when all through the house not a creature was stirring, not even a mouse. Except for that bloke dressed in black just down the road there who seems to be trying to case my house as though he's going to break into it and steal all my Christmas presents. Let's find out why these two items here can prevent that happening to you. Here we have the standard NeoPixel ring. This ring actually comes out of a much sort of bigger arrangement that the manufacturer, or the supplier at least, has broken up. They come in a big ring, a medium ring, this size, and then a little one in the middle, and they just simply snap off. I think you can probably make out on here a little tiny nub where you can see the actual physical PCBs were connected, even if they weren't electronically connected. And this was reasonably cheap. I think it was about £3, something like that. We'll have a look at it a little bit later. And I demonstrated that you could, take any one of these LEDs and turn it to any colour you want at any brightness, independently from any of the others. That's great. So it was a toss-up really between making a TV simulator, which is quite easy to do, and a wake-up sunrise simulator, which is also quite easy to do, but would require a little bit more complex programming in the sense of, well, you need a real-time clock or a GPS module to get the time. And I thought, well, for demonstrating the use of this, I don't really need to make it that complex. I can just use it as a TV simulator. So let's think about what needs to be done to make this work. So rather than reinvent the wheel, so to speak, I did take my lead from this commercial unit, simplistic though it was a little bit. I mean, there's lots of white LEDs on there, which is why it's really blinding on the camera now. There's, I think, one red LED in the middle somewhere, 2 blue LEDs and 3 green LEDs. And the only other thing it does is change the relative brightness of those LEDs, mainly the white ones, I think, to make it look like a TV scene being cut. Okay, so we start from that premise. So what did I do on here to make anything any different? I mean, these are also quite bright, especially the white ones. Well, the first thing I did was say, given the white LEDs, which are the first N LED starting from where the cable comes in, it's now you saw that go off. We'll talk about that in a minute. It's between 1 and 4 LEDs that are bright white. I say bright white. There's a lot of randomness in this, and I wanted it to, well, be seen, of course, through a semi-open curtained window or something like that. So I made a list actually of all the things I thought were necessary, and this is my list. We wanted to do a cut, so there's like on a TV scene where you cut between one scene and another. So somebody looking at something, you cut away to somebody else looking at the same person. So cuts and or partial cuts, so that you have a cut, but a car draws up within that scene, so that the picture changes, but it's not a total cutaway. There's blends where one scene fades into another, but that's not very usual on a TV program. A blank, like you just saw then a second ago, where everything sort of goes dark for half a second, where you might have either a fade out or a night scene or something like that. And the whole point about all these, I want these to be variable in frequency, and I wanted them random, not pre-programmed. I didn't want to have to specify a byte array or something to say do 3 of these and then 1 of those, then 6 of these, and then go back and make 4 LEDs on here red and 3 white. I didn't want any of that. This is, after all, a TV simulator. It's supposed to be random. And I did want to control the brightness per cluster. By per cluster meaning, for example, on those white ones, I wanted to be able to control the white ones independently from, say, the red ones. Now the good thing about this, of course, we have got a fixed 12 LED ring. It doesn't have to be a ring, it could be any number of LEDs, incidentally. It could be a strip, it could be anything, but it's fixed, so we know how many we're dealing with. The position's totally unimportant. I mean, whether the white are in fact the first N LEDs or scattered about would make absolutely no difference to the final result. Ditto the green and red and all that, it just doesn't matter. And yes, the white is definitely the most important, in the sense that it's obviously the brightest, and therefore the most dominant colour, if you like, to make the thing actually show up against a wall or a ceiling or indeed a blind or something. So based on that assumption that I've taken from here, more or less, I thought, right, what do we need to do? And I've made it, to be quite honest, as simple as I can. I've tested this out in a totally dark room, and I've got to say, I think this one works a lot better than this one. It's a lot more realistic, quite frankly. I mean, this one looks great in its little box and things, but you could easily put that into a similar transparent lidded box and put some diffusing plastic on the front. The diffusing plastic that I've got, in fact I've got some downstairs, I'll have to go and grab some out of the workshop just to show you. It's very cheap, you can buy it on eBay, and it does diffuse quite nicely. In the interim though, I just created a little foil cup. Obviously I was worried about short-circuiting things, but this is it's all surface mounted components, and as far as I could tell there was nothing on the back that could short out apart from where we actually plug the stuff in. So I just put a blob of blue tack on there, put this in here, fed the wires through a hole somewhere wherever it is, and use that as a reflector, and quite frankly it worked brilliantly. So, you know, to put that into a proper little project box and whatnot, it could literally stop people breaking in, I guess, or at least thinking the TV's on as they steal your car off the drive itself. But well, that's something else, isn't it? Okay, so let's have a look at the code, because the code is quite simple. I'm using that FastLED library that I did mention last time, and there's a lot in it. I did read quite deeply into the examples, but I thought, stop. This is a TV simulator. We're not going to the nth degree here. It's a starting block, isn't it, really? If you can understand the code that does this, and it's fairly simple because we're standing on the shoulders of giants here, aren't we? I didn't invent that FastLED library, and it's been around for a long time, so it's nice and mature, works really well, still being actively developed. So we're standing on the shoulders of the giant who created that and just consuming that, and well, making this do what we want it to do. So let's have a look at the code, and it's pretty simple code actually. So let's do that next. Okay, here's the code then. Now this is taken from the demo code that I created last time. So we've got the library here, the FastLED library, the number of LEDs. If your ring or strip contains more or less, remember to put that in here. The data pin we're using is 2, but well, it could be anything. And you create your object containing the number of LEDs like this here. You initialize it here. I've initialized the random number generator because we're going to be using that quite a bit here to make this as random as we can to stop us having to create byte arrays. I did have a debug window created here too, but I've not actually used that. The code is fairly simple. So how does the code work? Let's have a look. So within our loop, the first thing we do is clear the entire data array, and you must set this to true here to actually make this go blank, otherwise it doesn't actually write anything out to the display. Clears it internally but doesn't change anything on the output. So set that to true and it will blank it out, which I think you've seen once at least on here. Then we say, well, how many white LEDs do we want? Now of course you can play about with this to your heart's content. I've chosen anything from 0 to 4. I think 4 might be a little bit too many actually. Certainly when I tested this out in a totally dark room, well, even a couple of LEDs was enough to read by. So 4, I don't know, you'd have to play about with it, but to start with, 4 LEDs are fine. However, the 4 LEDs are not all on full brightness. We'll come to that in a sec. What I'm saying here though is that if we have no white LEDs, so the random number generator has said, well, we haven't got any white LEDs at all I'm saying here is create a small delay here and keep the display blank, because remember it's being set blank up here. We've not actually generated any output yet. So I'm going, well, if there are no white LEDs and 1 time in 4 here, make this a random 1 in 4 count. So if you like, 1 in 4 here is going to be we haven't got any LEDs, and then 1 in 4 we're saying, okay, make the actual display go blank as well. Okay, now the LEDs themselves, the white LEDs this is, which we're setting first, what we're saying is this is where we're setting the hue value. Now the color can be anything because we're not actually using a color, because the second parameter is 0, which means no color whatsoever. It just a white. So it doesn't matter what you choose in the first one there. And then the brightness, which is the third parameter in this CHSV call, is how bright you want it. And I'm saying, well, 10 is effectively off. Not quite. I mean, if you actually were to actually look at one of these, there's a couple on here now, for example. Let me see if I can get one before it changes. I mean, that one at the top there. No, it's changed too quick. But if you just look at this, where they seem to be going off, apart from now when they all went off, when there's that one there, for example, seems to be off, but it's not actually off. It's actually down to 10. I'll leave it as 10 though, because you can just see that little tiny glimmer. It wouldn't have any effect on your sort of wall or blind display, but it lets you as a programmer see that, yes, it's not actually off, but it's as good as. And the maximum brightness is, of course, 255. 255 might be a little bit high. As I say, this was extremely bright in that dark room. I'd have to actually go outside and check it from outside to see how well it looked. So you might want to play about with that as well. Okay, so having got n number of white LEDs lit at various brightnesses, we then say we'll fill in the remainder with just random colours, basically, also with varying degrees of brightness. Let me just take off that one there. Right, now we can read the code. So what we're saying is, for each of the remaining LEDs, go and grab a random colour at random intensity and at random brightness, obviously with some caveat. So we don't ever want it less than half colour. So if it was red, we don't want it ever more than, say, pale red. We don't want it so pale that it starts looking white. We've done white up here. And the intensity, as I say, is between 10 and 255. That could be adjusted. Anyway, then we show what we've generated so far. Have a little delay between 100 milliseconds and 2 seconds to give that sort of that cut between scenes on a television, and that's it. That's all the code there is. Simple, isn't it? What else can I say about this? If you were to download this and actually make this, I think you'd be surprised the difference between actually seeing it here on a workbench like this, where it's just running, where some LEDs seem to be lit, some are very, very dim, some are bright. Once you actually display this in a dark room, hold it up against a wall or something, and it has to be totally dark or pretty much there, you'd be surprised how effective that is as a TV simulator. Certainly when I was doing this in my workshop and all the lights were off, 100% darkness, I would not know that there wasn't a TV running in that room, because the random nature of these LEDs really does make it look like there's something happening on a TV screen somewhere. So that's all there is to this, really. The things that you can do on here, of course, you can have many more LEDs, but then you don't want them particularly bright. You can also have them in blocks, but that's a step that I didn't take for this particular demo. So you could have 4 LEDs of a colour and then 3 LEDs of another colour. The library supports that. I thought, well, let's keep it simple. Horses for courses and all that. And what else? Well, actually, it'd be interesting to know if this would run on a Tiny 85, a SparkFun Tiny 85, because, well, it's almost wasteful, isn't it, using a whole Nano on this. However, cost-wise, let's have a look at the cost now. If we consider a Nano is about £2, it's gone up a little bit in British money because of our exit from the EU. It's made the currency drop in value. But in dollar terms, it's still about the £2 equivalent mark of what it was before that. So that's a couple of quid. I think this was 3. In fact, we'll have a look at that in just a sec to see how much that was. And then you need to put all this into some sort of box with a reflective background, all that Fresnel type plastic, which I'm going to dig out in a sec. And of course, you've got to power it from 5 volts. Incidentally, I'm powering this from the V-in, not the plus 5 volts, because I didn't want it going through the regulator that's on the underside of this board. There's no need. And once you get a certain number of these LEDs lit up, you could overload that regulator. Now, I think with 12 LEDs, and of course there's 3 within each, that's 36. I think it might just about do with the 500 milliamps, because after all, the USB supply itself is only 500 milliamps, because I'm powering this from a hub. and it's not complained. But you have to be a little bit careful. So I've powered it from the V in anyway. Why have it going through a regulator when I don't need it to? So V in, and it works fine for 12. But if you're powering a whole strip of 144 or something, then you do have to power it independently, not going through this board at all. This USB socket is not designed to take that much power. So you literally have to take the power off here and plug it directly into a plus 5 volt supply. Ideally something like a 2 amp supply. Right, I'm going to try and dig out that diffractor or diffuser type plastic that I've used on a couple of spotlights outside my house. And then I think we can say that the cost of this is probably on par with a commercial unit. But we have the ultimate control, and if you think, no, I don't like that pattern, or I want it to stay on longer at certain periods, then of course you can do that, can't you? Because you are in control. And the satisfaction of having built it yourself. Right, let me see if I can find that diffractor plastic. I'm sure it's down there somewhere. Back in a sec. Okay, I've actually found 2 sets of plastic that I've used outside in my garden for an infrared diffuser, because we film wildlife and we've got an infrared floodlight, so we need to disperse that infrared light across the garden, otherwise it end up like a beam. We don't want that. So there's this stuff here, which, as you can see, if I'm holding it above there, you can see it's all sort of knobbly and little triangular prisms and stuff, and that works really well. That's more of a diffractor really. And then there's this stuff which is solid white, and it's still got a protective piece of plastic on as well, but never mind. I mean, that's a little bit different, isn't it? That makes it just sort of, I don't know, milky white. You can probably just about pick up the cameras. As I've mentioned many times, there's a certain sense of frustration I get when I'm trying to film LEDs, because you're seeing now, you see, big blobs of white on here with a halo of colour, which I can see quite clearly on my monitor as I'm filming this. But in real life, there's no white at all. I'm looking at this now, and there's no white at all. These are just pure rings of colour, pure blobs of colour. And very nice they look too. So you'll just have to use your imagination a bit on there. So that's what that looks like. And I don't think that would work as well as this sort of diffractor stuff. You'd have to place it probably, I don't know, ½ an inch away. I think that's what they did. Yeah, that's what they've done in this commercial model. They've got the actual LEDs back about 1 centimetre or something like that to make that work. And I think you'd probably have to do the same on here, about there, because it makes it look like that. Actually, we seem to have stopped. I don't know what's happened here. Let me just reset. Have I pulled something out? Oh yes, I pulled the data pin out. That's what it is. Let me just connect that back in again. Pin 2, I think it was. That one. Yes, there we are. Right, off we go. So there we can see now, you see it is diffusing it quite well, subject to that caveat I said about the white that you're seeing on here. Incidentally, when all the LEDs go off like that for well, anything from 100 milliseconds, I think it was, to 2 seconds, it really does, well, it's effective. Let's put it that way. It doesn't look as though things have gone wrong at all from outside. It just looks like a TV. It's quite amazing. That's quite a good effect. Look, using that diffractor. And when this is, as I say, in a dark room and it's being displayed through this plastic, it's very effective indeed. Now, I tried to find out where on eBay I bought this, but it's so long ago that I can't find it. Neither of these, but I have got something here I can show you. If I go to the browser window. So instead of hard plastic, you could, of course, use sort of PAR 36, or oh, it says PAR 64 here, but basically it's theatre quality diffuser. This is heavy frost, it says here, and I've used this actually outside. And it's quite a thin sheet, but made out of plastic, frosted, and it does diffract the light, or at least diffuse the light quite well. And that's only £1.80. I think it's an A4 sheet on there, something like that. Anyway, does it say? Let's have a look. No, it's probably big enough for a PAR 64 light, but whatever, it'd be enough for this project. So there's all sorts of things you can do, and I certainly would recommend in doing something. I mean, even a piece of greaseproof paper would work better than just leaving it sort of naked like this, it's probably not going to have the best effect if you just leave it naked like this. Even this little cup that I made out of foil just to test things out on worked brilliantly well, and it allowed the light, of course, then to be focused against a ceiling or a wall or a curtain or a blind, and that worked really well as well. But this is only proof of concept, obviously, just to check things out. I wouldn't use that in a finished product, but maybe you could use foil behind it anyway, a thinner version of this, a much flatter version. That's where the joy of building projects comes in, isn't it? You can play about to your heart's content until you've got it right. Okay, I think we sort of covered all bases there, really. I'm going to put a link down to the library that I'm using, which is this one here. Let's go back to the top. So it's the FastLED library. It's the same ones we used in the demo before. Brilliant it is. Got loads more features than what we've covered here. But as I say, if you get to the point where you can understand what's going on here and how I've updated some of these LEDs and the brightness and so forth, then I think you're on your own anyway. Your project is already on the move and you don't need me anymore. Okay, that's it then. I think we're done here. So this is where I actually bought that ring, and in fact it's cheaper than what I remembered. As you can see, it's $179. That's what I paid as well, and it's probably one of the cheapest on eBay at the moment for a 12 LED ring. There's lots of others available, as I say. This one was from, I can't even pronounce that. What does that say? Bay Home or something. Anyway, it's pretty good, all pretty standard. They're probably made by the million, so get out there and experiment. That's why I say, what have you got to lose? Here, I'm going to actually put this into some sort of box arrangement and replace this commercial unit, which I'm going to continue to use at the back of the house, and use this one here at the front of the house. And hopefully no nasty person will break into my house and steal my Christmas presents this Christmas Eve. So with that thought, I wish you a very Merry Christmas, and if you are watching this in the middle of June, make allowances. Okay, thanks very much. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.